Swayam Prabha. Digital India. Educated India.
Welcome to this lecture number 19. So, in this lecture we will continue with what we started in the previous lecture, that is lecture number 18, which is the concept and methods of artificial groundwater recharge. And after completing this, we will move on to recharge mounds and induced recharge. So, first we will continue with this concept of artificial groundwater recharge, and here, so basically this artificial groundwater recharge is necessary to supplement. So, this is the concept of artificial groundwater recharge. So, here it is to supplement the natural groundwater recharge which in many cases, many situations may prove to be inadequate to different degrees. So, it is just like say for example, the natural lighting, which is I am just giving an analogy. The natural lighting is always from dawn to dusk, but the human activity has developed or extended to such a level, so that even once the sun has set, that means the dusk has set in. So, still the human beings, the human society, and we want to do more work, and we want to engage ourselves in more activities. So, in such cases, so we need to go for artificial lighting. So, this is on a temporal basis and spatially also. So, even in the broad daylight, so some areas, so they may have insufficient lighting. So, in that case we may have to take the help of artificial lighting. So, similarly, so this there is always this inadequate in different degrees, both spatially and temporally. That means both space wise as well as time wise. So, this natural groundwater recharge may prove to be inadequate. So, this it may be slightly inadequate, or it may be significantly inadequate, or it may be totally inadequate. So, it all depends upon the actual situation, and so therefore, here, so this groundwater recharge, and obviously, so this common sense says that, so in areas where there is waterlogging, that means excessive this natural groundwater recharge. So, then there is no question of this necessity of this artificial groundwater recharge. So, with this concept, and then so there are many formulae to estimate the natural groundwater recharge, and and of course, once we estimate the natural groundwater recharge, so we may find that the amount of volume of water which has gone into the that is the subsurface spaces, which may be aquifers, or it may be even wells, or it may be any other subsurface storage spaces. So, in that case we have to adopt this artificial groundwater recharge, and thereby so we improve our water security. So, this it improves that is water security stroke availability in general, and groundwater security stroke availability in particular. Okay, and so now let us briefly discuss about this purposes of this artificial groundwater recharge. So, let me abbreviate this as AGWR. So, purposes of artificial groundwater recharge. So, the following are the main purposes of artificial groundwater recharge. The first one is to maintain or augment, this is the most important one, natural groundwater as a resource. And this resource, it is a economical resource as well as overall resource, because there are certain parameters which cannot be quantified economically. So, like say such as the intangible benefits. So, once this artificial groundwater recharge is adopted or is employed, so then it will also result in other intangible benefits like improvement in flora, fauna, and other things. So, which all of which may not be quantified. So, second purpose is to coordinate the operation of surface strokes subsurface reservoirs. Okay. So, this is the second purpose of artificial groundwater recharge. And then thirdly, the third purpose of artificial groundwater recharge is to overcome adverse conditions, conditions like progressive lowering of groundwater level, unfavorable or undesirable salt or salinity balance in water. So, which includes salt water intrusion also, or salinity intrusion also, or it's a brackish water intrusion. So, this is the third purpose, and the next one is to provide additional subsurface storage for local or imported surface water. So, once we have this, once we employ this artificial groundwater recharge, so then it provides an additional storage, additional reservoir, subsurface reservoir, which can be used for, so which can be used either locally or which can be transported over short or medium or long distance. So, to meet the appropriate water use. So, next is this is to reduce or completely stop subsidence of land significantly. See here, so once this artificial groundwater recharge is adopted, so it will improve the soil balance, that is, I am sorry, the moisture content in the soil, and thereby, so it will improve the strength of the soil. So, it will be less susceptible for erosion. So, therefore, and not only this one, and also what happens is it will be less susceptible for subsidence, and like the foundation and all. So, it is the foundation, that is settlement of foundations. Okay, so unequal settlement, or it can be even totally that is almost it is total settlement in all the areas. So, such which results in land subsidence. So, that can be reduced or stopped completely. So, that is this one, and then so the next purpose is to provide locally subsurface distribution system So, this is subsurface water distribution. Subsurface water means basically groundwater distribution system through established or newly constructed wells. So, here, so we will ensure that, so there is an adequate supply of subsurface water and the additional adequate supply of subsurface water, which can be harnessed through either this already established wells or existing wells or newly constructed wells. So, then so this is the sixth purpose, and then next is to provide treatment stroke storage for reclaimed wastewater for subsequent partial or total reuse. It is said that the solution to pollution is dilution. So, therefore, this wastewater, when it is reclaimed, so there the artificially recharged groundwater, what it does is it will ensure that the that is the reclaimed wastewater is further diluted, and so thereby the concentration of the pollutants in the wastewater is further minimized, and many times it may be within the permissible limits, or it may be even almost be much below the permissible limits. So, in such cases it can be used either for partial reuse or total reuse. So, here in this case I can give an example of this new water. So, basically in Singapore, wherein so some fraction, maybe 5% or say 10% of the water which is being supplied is added with such treated reclaimed wastewater. So, and then so that is this one, and then lastly to conserve or extract energy in the form of hot or cold water. So, here we know that there is always an optimum depth below ground where the temperature variation is minimum, and we can utilize this fact to our advantage, and then so we can create a reservoir through this artificial groundwater recharge. You can create a reservoir, so which may be of great help, especially in winters, and which is also known as passive air conditioning technology, and so or in summer when it is too hot. So, that time, so it may provide it may be able to provide water which is significantly colder than the extreme summer temperature. So, all this can be, so that can be, so we can utilize the that is the ground as a reservoir or insulator, wherein so this temperature can be, so temperature variation can be reduced. So, these are the purposes, and based on these purposes the concept of artificial groundwater recharge is hinged upon. So, now we will go to the methods of artificial groundwater recharge, methods of AGWR. So, that is artificial groundwater recharge. So, there are various methods for this artificial groundwater recharge. So, let us list these methods and then briefly discuss one by one. The first one is the basin method. So, this is followed by stream channel method, and then the third method is this ditch and furrow method. Then there is a flooding method. The fifth one is the irrigation method. And the next one I am writing here, that is the pit method. Then lastly, this is here, let me write here only, the recharge well method. So these are the 7 methods of which are generally used for artificial groundwater recharge. So now we will briefly discuss these methods, and these methods are the names of these methods, the titles of these methods of artificial groundwater recharge are self-explanatory. Now first let us go to this basin method of artificial groundwater recharge. I am extensively using the abbreviation AGWR, which is artificial groundwater recharge. And here, this case, say basically what is done is, see, whenever there is an excess supply of surface water, so this surface water is stored in a basin which is in the vicinity of the stream or a water body. And in this case, say for example, say suppose this is there is a stream, say suppose there is a stream, and let us consider the let us say the flow is from right to left in this stream, and here what this basin method does is, so an additional basin is created and so this is the stream or river, and then this is the diversion structure. So it could be a small weir or a barrage, and here so this is the intake structure, and here this is a sediment retention basin, or which is simply known as sedimentation basin, and followed by, so this is so these are let us denote this as B, and here, so that is like this. So this is these are A, so here this A represents a recharge basin, and this B represents, that is interbasin control structure. Control or regulating structure. So this is a typical plan, or say top view of a multiple basin artificial groundwater recharge scheme. So it will be like this. So basically, so here what happens is, so this is it is in the same direction. So initially there is an diversion structure which will create, which will augment the head, and then so the water is diverted through the intake structure, and then from the intake structure it passes through the sediment retention or sedimentation basin, and then so there is the intubation control structure. So here, by closing this bottom one, that is the below one, we can ensure that so these top three recharge basins can be recharged, and similarly if we close the top one, so this one we can ensure that so there is recharge only in these bottom three recharge basins. So like that, so this is the basin method, so in which the area which is in and around the water body such as a stream, okay, wherein it is feasible topographically as well, so can be employed, and so here this will induce, so because of this large area of the basin, so the flow velocity of water is significantly reduced, and then so therefore it will result in this it will induce artificial groundwater recharge by significantly through infiltration. So initially the top aquifer, that is the unconfined aquifer, is getting recharged, and then again this subsequently it also results in the recharge of lower confined aquifers, of course. And if you want to further increase its S1, so then obviously we have to use appropriate techniques so that it can be done. So this is the basin method, which is the first method of artificial groundwater recharge. So now let us go on to the second method, which is the stream channel method, and of course in this case the so here let me, so the second is the stream channel method of AGWR. So here, so what is done is, suppose, so this is the top view of a stream. In this case, a check dam may be constructed along the so this could be, so this is a stream and then this is a so this is a rock and wire check dam. So this is basically, here you can this is a, so that is, it is a dry rubble masonry. So here what happens is, this dry rubble masonry, which forms what is known as a check dam, so is constructed across the length of a stream or a river, and what it does is, so initially it will all the finer sediment particles which otherwise would have flown along with the stream water. Okay, so these are trapped, so their velocity is significantly reduced, and then so these finer sediment particles, so they basically get deposited in the that is the intermolecular spaces, or say that's in the interstices of the this dry rubble masonry. And then so what happens is, so this is initially it will start as a soil conservation measure, and then it also conserves water, and then eventually it will conserve vegetation also. So which are the three important parameters to be conserved in integrated watershed management. So therefore, so the stream channel method, in this what happens is, so this is the suppose this is the here let me show, this is the original extent of stream channel, and then the improved extent. So because of this construction of this dry rubble masonry and all, so what happens is, so there will be an additional storage of water. So this is the, so here so this is the improved extent of stream channel storage after this artificial groundwater recharge. And here, so this is the original extent of stream channel. So this is the original extent of stream channel storage. Okay, so this is the second method of artificial groundwater recharge, which is the stream channel method. And now let us go to the third method, that is the ditch and furrow method. So this is the third, is the ditch and furrow method of AGWR. So, in this what is done is, so this is ditches and furrows are created, so that say this is the, so suppose if this is the original land profile, so this is the so here this, so here certain furrows, so these are the furrows, and then so this is maybe some this ditches also. Okay, so these are the ditches, this as well as this, and then so these are the furrows. So they are all basically this earthen one, or they may also have this one. So these are the furrows. So the new so this is the modified land profile. So by creating this ditches and furrows, so we are going to increase the water retaining capacity or water withholding capacity, and which will eventually result in artificial groundwater recharge. So this is the third method, and so the fourth one is the flooding method. So here it is self-explanatory. So in this case, simply water is allowed to flood. So the precipitation water allowed to flood along the surface at the desired location or locations such that there is no mosquito. So that means it is also known as a vector problem. Mosquito menace problem. Okay. So by doing this, so that is we may adopt various methods, so that flooding is there, but at the same time, so there is no growth of mosquitoes and undesirable organisms, and so therefore, so this is once this is the water is allowed to flood, so then it automatically it will recharge, that will flow by gravity in the vertically downward direction, and then thereby this artificial groundwater recharge is achieved. So next is, that is the irrigation method. So, here also it is self explanatory. So, in this case, so what is done is, that is so this is crops are excessively irrigated so that they can overcome this crops are, so that they can overcome the water shortage problem in the near future, and also better utilize the existing excess availability of precipitation water, or say rainwater or precipitation water. So, this is the irrigation method, and of course, so once the excess water is allowed, so then so we may reduce the irrigation frequency, and then we may even go for this deficit irrigation, so that even if there is slight delay in the monsoon or this one, so the plants are self sufficient to overcome that situation because of the that is the already achieved this one, that is what I should say, the because they already achieved that water availability. Okay. So, this is the fifth one, and then lastly, so there is a pit method. So, this pit method is also so that is the sixth one, is the pit method of AGWR. So, this is self explanatory. So, this pits of appropriate sizes size stroke shape are dug at suitable locations wherein excess water can get stored and bring about and say eventually bring about artificial groundwater recharge. So, this is the pit method. Okay. So, these are the 6 methods of artificial groundwater recharge, and of course, these are not exclusive. So, we may adopt any new method which may be this artificial groundwater recharge. So, to give one simple example, so I can mention here, so that is the terminology of rainwater harvesting is very popular these days, and of course, so this rainwater harvesting is essentially, it is also one form of artificial groundwater recharge, and in this case I would like to bring it to the notice of this one. of the fact that a village lady, that is in interior coastal, rather in coastal Karnataka near the town of Mangalore. So she uses her old saris, and so she spreads these old saris around this one, and then so the coastal area, which is having a relatively large amount of humidity, so this water, the humid water, it gets this one, and then eventually, so there will be condensation of this humid water, and then so she gets maybe some amount of maybe few liters, depending upon the size of her sari and all that, as well as thickness of as well as the material. So she gets this one. So like that, so she bring about that is harvest or the locally available excess moisture, and okay. So with this they'll complete this one, and now we'll go to what are known as the recharge mounds. So these recharge mounds are essentially the mounds or humps which are created by artificial groundwater recharge. So these are here you can write down. So these are the mounds, the humps or mounds so these are the humps or mounds created by this artificial groundwater recharge. Carried out on a sustained basis. And here let me draw a typical this one, the cross section, as well as and in this case, say for example, say suppose this is the so this is the ground surface, and here suppose this is the square recharge basin, and here this is here this is a regular shaped, so which in most of the cases may be recharge basin square, and here what happens is that is say suppose so this is the here you can say the average length of this one is A, the regular shaped recharge basin. So let me just differentiate. So here what happens is, so this is the initial water table. So this is the original water table or piezometric surface. Let me write this as and then because of the storage of this water in this recharge basin, so here what happens is, so it will form a mound here. Okay, so this is the water table during or during stroke after artificial groundwater recharge. So therefore, this is the recharge mound is created here because of this the recharge in a regular shape basin. Then so this is a typical recharge mound. Then we will go for this is the induced recharge, and in this case, anyway, I think we will stop here and we will continue with the induced recharge in the next lecture. And okay, so thank you.